Okay, welcome back from lunch, everyone. This is our session that starts with a panel on MLIR and is MLIR feature ready or feature ready. Feature complete and production ready, or feature ready is a good title as well. I'm Zinenko, I'm moderating the panel, and we have a great set of panelists here with Mehdi from NVIDIA. Mehdi worked on MLIR a lot and on various LLVM projects before. Renato from Intel, old school LLVM guy, I guess, also some MLIR interests. Stella from AMD, who has a big team working on MLIR and the IREE project. Tobias was our first academic partner, I would guess, and now has the biggest academic group using MLIR and doing MLIR. Don't want to include me there. And Chris, I don't know, he was just a random guy hanging around at LLVM conferences.
We needed 7 people.
Yeah, we needed more people, so it looked nice.
I was in town.
Yeah,
so.
I mean, he was in town, so like, yeah. I hope Chris needs no introduction in this venue, but otherwise Chris created LLVM, MLIR, and many other things. So welcome. And while I have this slide, this is actually not the working title for the panel I had.
I knew that was going to happen.
So I was...
Just get it out of the way at the beginning.
Yeah, that's a nice panel. I was thinking, is there something I haven't talked about at the LLVM conference about MLIR, and I really wanted to come. And I decided to look at things like, what have I done in the past years that I can come and talk about? And I decided to go look at my commits, and I didn't do much. And then I decided to look at what other people have done at upstream MLIR, and it turns out people haven't done much either this year. So when I submitted this in August, I made the stats, and we had like around 2,000 commits with MLIR tech in 2023 until August, and around 1,000 commits, so half of that in 2024. I made the stats for ODM just this morning, and we had 3 MLIR open meetings this year until today, and we had 14 the last year, and we had like 20 the year before. So the working title for this panel was, is MLIR kind of dying? Why are people not contributing? So that's my first question to the panel. Is MLIR kind of dying?
Right.
I mean, look at the crowd.
Go for it, Tobias.
Yeah.
Oh, I think they just came to hear a bunch of unopinionated people.
Yeah.
The funeral.
I think, yeah, Chris, the funeral, right? Thank you for attending.
It's super funny because people ask me all the time, is LLVM dead now that MLIR is taking all the, now that MLIR is the thing, so.
Yeah, but I think what I like in the context of a different open source project, what I like, I like the terminology of like kind of a cathedral style development model and kind of a more federalistic development model. And I think from my perspective, what we see with MLIR, I think there are plenty of features that I'd like to have in the like MLIR core. But I think we also like, as an LLVM community, which was a relatively more towards like a uniform cathedral style development model, I think MLIR is very much the other thing. We created the most federalistic compiler organization that I've seen so far. And I think that's something that's very uncommon for us as a community. So it poses a lot of challenges. I mean, in our research group, we built we copy MLIR, we built something like XDSL, which is also really unusual. I was a core LLVM developer. All my code was in LLVM. And then suddenly we kind of ripped this ecosystem into pieces. And I think that has a lot of problems, but I think it also has really new opportunities for us as a community. And maybe, yeah, that's kind of my take on what we are seeing.
I mean, my take, Alex, you're being awesomely provocative, so please keep doing this. There's more of a graduation thing going on, right? So another interesting chart, I don't know about the data, is if you look over the last 6 years that MLIR has been a thing, what percentage of the talks at LLVM meetings are about MLIR and its users? Right?
Well, I actually looked at that, and that number was not going my way, so I did not put on the slide.
Okay. I'm sorry, I didn't serve your purpose, right? So.
Yeah, but okay, I did a number I can give you that last year at this event we had 10 talks with MLIR in the title, 10 long talks with MLIR in the title. This year we have 9, so 9, 10 is kind of the same. If you count Mojo as MLIR, we actually have 13. So it's more, if you count XDSL, we have even more.
Well, but it's also all the users, like the Linux, and like there's tons of people doing lots of stuff, and a whole workshop, and
TensorRT and all the others. It's all MLIR connected.
But so what I would look at is like to just like interpret your data a bit. So when you look at the ODMs, well, it's because MLIR's graduated from let's teach each other what MLIR is into a lot of people being able to use it and get value out of it. And I think that that to me is, you know, a very good sign of success. It's not about is it interesting from a science perspective. It's is it practical and is it useful and is it getting built and deployed.
Mehdi, you wanted to say something?
Well, first I wanted to thank Tobias to qualify MLIR as a federalist system when many people would qualify it as an anarchist system. And so I was like, that feels so much better to think of it this way. Thanks. And I was about to say the same thing as Chris said, you know, the open meeting that we had have been a lot about solving problems in MLIR itself, the infrastructure, understanding the needs of the user and outreach. In the first years of the lifetime of MLIR. Maybe that's a sign of maturity now also, that we have less problem with the core of MLIR, the infrastructure. We have less to explain new things and new concepts. But also the system gets used much more by users, and so that's why we don't see a decline in the number of talks using MLIR at the conference. And we even have the workshop the day before the conference was very successful. With more participants than ever. I don't even have the final count. I'm still waiting on the numbers, but it was very, very attended and talks of pretty high quality. I found that very, very good content. And so that's another side of the where we are with the project.
Yeah. To be honest, it was kind of challenging to find those talks to start with. Like we really had to push people to come and present, and that's one thing that I kind of observe as a trend is it is indeed being used more and more, and we kind of diverge from the, I'm not sure it was really a charter in the beginning, but part of it was like, I remember Chris on stage saying, I don't want to do yet another canonicalizer or yet another pass infrastructure. And okay, for canonicalizer and pass infrastructure, we kind of did that.
Yeah, solved.
Yeah, but for the rest of the thing, do we really want to do yet another arithmetic? Do we really want to write add x plus, like x plus 0 equals x again? And it looks like people are increasingly turning to downstreams, and that to me diverges from the original idea of let's not reinvent things, and we're kind of back to the mode where people with especially big groups tend to reinvent things in their own way.
Well, so let me also
can I jump in? Please. Jeff, you won the bet on
Yes.
how long it would be until canonicalizers got brought up. So.
Less than 5 minutes.
I was just going to say, to continue being provocative, or to make it a provocative way, people, again, I try to be friendly and try to help answer questions. People ask me things like, hey, Chris, you said 6 years ago that you hoped that MLIR would help unify all these compilers. Why is everything so fragmented? And so me being the optimist, the way I look at this, I say, well, can you imagine what all these domain problems people are talking about solving and using MLIR for today, what these teams and what these people would be doing if MLIR didn't exist? Like, think about it. Think about just like the MLIR workshop or something. Like all these domain problems for all these fancy chips, all these different domain problems, like they'd probably, the chips would exist, right? But what would happen is you'd have even more fragmented sub-communities of individual companies, like not able even to speak the same language, right? And I think the MLIR first charter, which I think it's a great framing, Alex, is like it didn't have to unify everything. That's impractical. People do have different problems, right? But unification isn't a binary question, right? And so even if you just unify pass managers and canonicalize and ODS and the concept of a dialect, and like even if you just do that and you don't even have dialects, like that's still significant progress in terms of I don't have to reinvent SSA again, right? But then if you say, yeah, RIF, actually RIF is widely used, LINAG is widely used, like a lot of these things are widely used and very practically useful. Well, that's actually a huge contribution for those domains. Of course, Tobias will tell you, like that doesn't help a lot for hardware design. But then you go look at CIRCT, and it's like, oh, okay, well, actually, there's some pretty cool stuff happening here, and it's, do you attribute that to MLIR? Well, it wouldn't exist without it. And so there's like these different ways to look at fractally the contribution over time.
I'm just not sure it's the same language they were speaking. We might be talking about arithmetic, but arithmetic is different depending on the hardware. So one person says this works, the other person said this doesn't exist. So even though we are all talking in the MLIR area, So you get a lot of questions. I subscribe to all of the new topics in the MLIR thing, but only the first one, right? I don't want to follow the whole thing. And there's a lot of people coming in and say, oh, I see that there's this dialect, this, and there's this operation, which I think does this. Why doesn't it work? And then an answer comes along and says, oh, it's because it was not designed this way. This is not what it means. Do it this other way. Confusing. So I think, and the person says, thank you, goes away and does the, it's like when I started with LLVM, it's like, why my EDG pattern doesn't match the IR? Oh, it's because this is what Clang does, so do what Clang does, right? It worked.
There was an answer at least.
Exactly, yeah, at least that was an answer. But I think the design of IR that happened since LLVM IR has been, and especially Nikita's Rust presentation, that was awesome. This is what we need, right? It's like, okay, we have needs, and people have different needs, and what do we actually mean by these things, right? It's not just we're all talking MLIR, is we need to talk what MLIR is and how we interpret it and how we get to the solution that different people need, right? Without solving every compiler problem under the earth. That's the question I don't have an answer for.
Yeah, I think what I find like relating back to the topic is MLIR done or not? I think it's actually interesting to see what is MLIR, which parts are done or not, right? The MLIR basic block data structure, I guess it's mostly something we agree on, right? I think we really transition from like defining these core data structures to, I mean, maybe the last 4 years is kind of building AI compilers, and some of you say this is still a difficult problem, but that's also like where you have major industrial teams building these compilers, right? So they are the problems of how do we finalize them, how make them nice, maybe how to share more of our technology, but even that is a relatively mature ecosystem, I think. But I think the other thing that I almost would say, like we're actually at the very beginning, is if you look at really the breadth of MLIR across communities that have never been working together, collaborating together, I think we probably over the last years created one of the least organized, most diverse, most controversial communities in the kind of PL space. And some will say, okay, that is really deeply annoying, it's anarchistic, it's crazy. But kind of if you look at like some of the recent DARPA calls or whatever, where we really want to build like compiler technology that crosses way beyond the CPU model, I think step number one is to kind of create this mess. And I think we are like on day 2 of figuring out what we do with that mess.
Yeah, I think progress, it's super funny if you zoom out and you look at progress, right? You can always see that the world and technology and things are progressing, and it feels like there's a linear improvement in technology or GDP or whatever it is that you're looking at over time. But if you zoom into one of these things, what you realize is it isn't a straight line at all. What it is actually a gigantic freaking mess, and 2 steps forward, 1 step back, like things that work and don't work, and then the question is like, do you have a consistent value system? Do you have a shared notion what success looks like? And if you don't, then what happens is you do this and you get pulled all over the place. But if you're making progress and you're just disagreeing about how to do it, then you're still getting somewhere. But to +1 you, like, where is MLIR for biochemistry? Where's, the unification of SQL and query optimizers? Where, like, there's plenty of work to be done.
Well, there was MLIR for, I think, French law.
Oh,
I found that really interesting.
Yeah, there you go.
So, yeah.
Yeah, why is LangChain not using MLIR? Yeah.
I mean, part of the question, or the thing that I think of just because my brain has to work through ordered lists, is that MLIR is a lot of things, and what is it done, or is it alive, or is it dead? But what parts of it are done, and what parts of it are alive, and what parts of it are maybe experiments that maybe it's time to move on. And just looking over the last 5 years, which we've been building this thing for five years. It's
2018.
Yeah, it's I think that MLIR core is done in a good way. There's always things to do. There's always more to do. But like, I'm not going out saying, hey, you know what you should use? What's really cool? MLIR core. People already know about it. Like if you got this job, you use it, and a lot of the core stuff, and so part of me wants to say, while we're doing this walk through the woods, how do we lock that in? How do we make that production ready? How do we make that useful in all the things it needs to be used for, that aren't just, it's being used a little bit under duress sometimes because it needs some finishing, but that's where my mind goes. Someone asked me, how do you use MLIR to unify AI? I'm like, well, start by securing the foundation. Get MLIR core locked in. Let's get it layered right. This is at the good kind of done. Get the core software abstractions locked in. Get them layered right. Get people who are have described that and spec'd it out, and there's a charter for it. That creates the space to then say, okay, these things are done. Like now let's focus on some of the other stuff. ML compilers are still staggering around. That's kind of where this whole thing started, and then it could still go anywhere. You've got lots of bets being taken from language-based stuff like Mojo and Triton to more classic ML compilers that are op soup distillation. I don't think I've called it that before. I've called it many things, usually swear words, but let's give some space for that to go, but let's lock in what's good. Let's do that. Let's make it better. Let's make it so it's not part of the rest of the soup. I think that's how I would answer the question.
Well, let's say we agree. This is core. This is non-core. It's going to take some time, but let's say we agree, which means this is now graduated and this is undergrad. When things here graduate, they don't need to graduate into MLIR core, right? They can graduate to something else.
I think we should treat those things as project, like they don't need to inherit the original mission,
Right.
And like they should be projects, and they don't necessarily need to follow the same rules either of the Highlander rules if there can be only one, and that sort of thing.
There should be. Yes, that's the whole point, right?
Right.
Yeah.
And if they need to do things differently, so be it. But no, I don't think I don't think everything graduates to MLIR. You've got all of MLIR's children at this point, and
Yep,
they're
and
going
their
to
children, and grandchildren.
They're going to different schools.
Yeah.
It's fine.
To me, that
Sorry.
to me that raises more the question of like if you describe things as separate projects, then it's like what is the community around them and what is the mission around them? Because we're talking about departing from the mission of MLIR, and MLIR is in LLVM to fulfill a given mission. So if there are components that starts needing their own space and their own mission and their own rules, like that becomes incubator project or just separate project, separate organization. I think there are tons of successful MLIR-based projects outside of. Yeah. Not everything has to be inside LLVM to be successful.
Yeah.
That's probably as intended.
And I think it's more reflecting what already happened rather than trying to create something. So people already, as I said before, people already talk in different languages. Even though we all talk MLIR, they're worried about different things. So we're just basically saying these people flock together, those people flock together, and there's an intersection, right? So if we encode group set intersection, then it's not dividing the community, it's just making it clear which subsection of the intersection you belong to.
We're going to need a DSL for that. How should we build that?
A dialect.
So, yes, second, DSL and canonicalization. There you go, we've done it, under 30 minutes.
I was talking to Steve earlier, and he gave a nice analogy, which I think is really worth thinking about, is it's when MLIR came into existence, like conquering a new planet. The first thing you have to do is go terraform the planet, go figure out what the laws of nature are, go figure out what this thing is, and it's a very messy process. And now I think that we've conquered planet MLIR, but we need to make it livable. And so as we're getting to this next phase of evolution, I think that it's not about, so your numbers, for example, it's not about is MLIR done? It's about more of how do we structure the community, how do we figure out the tribes and get them factored the right way, how do we make it so the infrastructure is more clearly explainable, how do we make it so somebody new walking into the community and say, okay, that's MLIR the good parts, and this is MLIR the other stuff, right?
Yeah, and I guess in the spirit of being provocative, I think that like one way is to partition the kind of communities between kind of good and bad, right? what is good and bad. And
I mean,
bad community or
and obviously, like we as scientists, we are typically the black sheep, right? Like not delivering a product, not delivering production quality stuff. And yeah, I think maybe also like thinking about like what is still to be done. And I think maybe one kind of technology that hasn't been built a lot in the MLI community to the level I think that could have been built or should be built over the future is, do we actually have community management tools that scale to what we've built?
What do you mean?
Yeah, well, that's what I'm wondering. What do we actually need? Do we need more compiler technology to manage our ecosystem? Do we need something entirely different? Right? How do we enable efficient communication at a level that maybe doesn't scale to the LLVM mailing list? Right? I mean, historically, like when I wanted to contribute something to LLVM, I posted a patch, I have a conversation, like 10 people answered, and they say that's how you need to evolve Scala evolution. Today, when I want to do something in MLIR, I mean, how do I even reach out into all the different communities? How do I understand how far do I need to reach, right? I mean, there's this entire, like I call it kind of secret social engineering in the LLVM community. Like if I want to get something done, I talk with the right people, I kind of get things organized. I historically knew how to realize, like,
I think it's still the same
concept.
thing, right? It's still the same tactic, but it's just more people, larger things.
Yeah, and I think it
And
doesn't
you
scale.
don't know who the people are.
Right.
So like,
Well, so in the case of LLVM, right, there's clearly delineated subproject. Right?
Right.
And so if you want to go ask debugger questions, if you want to go ask codegen questions, if you want to go ask libc++ questions, ask whatever, like you kind of know where
Right.
to go, but MLIR is too monolithic. Like, and as it has grown, what that means is the community has grown, which is a good thing, but then MLIR is still one thing. And so because it's still one thing, right, the problem is that any of the individual stakeholders or participants or whatever gets a wash, I'll speak for myself, gets washed with all the stuff going on, and most of it, to your point, is not interesting. And so if we provide more scaffolding and more, like there's an AI subsection, there's a software subsection, I think CIRCT's already the hardware subsection, right? Then it could allow more focused community and discussion and more cohesion.
Yeah, but MLR is much harder to split than LLVM, right? Because if you talk about ML, you involve what? Tensor, memref, lineage, vector, whatever.
We've
And you
got
talk
clumps.
about, huh?
You've got some clumps.
You do, but these clumps are not necessarily mutually exclusive. So if somebody really cares about lineage from ML point of view or from HPC point of view or something, then they're going to be overlapping groups caring about different things.
I think it's possible to have too much of an ontology, and this group might be prone to that.
Yes.
I've described this before as, we're currently asking people to walk into a stadium and kind of self-find row 36F. That's where Linalg lives, and then like want to maintain row 36F. And that's just not how social communities work. There needs to be homes for this stuff. You need to create a sense where people can want to improve an area because there's people know who the main decision makers are, the main people with the experience there and can have conversations, and happen. I think that we just need to start fostering more of that in MLIR itself. Part of it is getting the technical dependencies, I would say, more encoded into the project before the core contributors stop caring and enforcing that. The project needs to be more of a DAG and less of a circle. But but more important to me for the health of a project is the social dependencies, which is part of what Chris is saying, part of what Tobias is saying, part of what Renato is saying, and for that you need structure, you need charters, you need people to understand what the component is, not just the entire thing, and that helps sort it, and it creates some optionality too. The whole thing doesn't need to succeed or fail, or not everything is the rock star situation, and some of it is it's all at different phases. But we need more. We need to let this thing grow into some standing clumps.
And the technical decisions the technical background may change over time, right? Because you see, I created this with this intention, but now it's used for a whole different thing. And this is part of it, right? You don't throw away because you said, originally intended for this one, so go create something else. No, if it evolves, it evolves, right? I think it's the lineage has evolved from, mainly one core thing to multiple things, and now part of it is my fault, and I was like, okay, that was the wrong way to go. Let's try to simplify now. And I think it's a valid exercise, right? Of course, I would prefer to have been right a year ago, but sorry. So
progress is messy, but
yeah, exactly. Yeah.
I guess one thing I'm wondering about is kind of like, I mean, there are social challenges, and I think that will be really interesting for us as a community to manage them. But for me, I think one of the things from like the LVM days, what I learned that our communities we use technical tools to organize our communities, right? So I think one summary of what LVM is for me is it's a like line-based diff format that is driven by file check. That is pretty much what the LLVM community is as a whole. We are writing file check test case. We know how to use Git well, and in a way that obviously is just a small part of what LVM is, but that organizes the community. And so I'm wondering a little bit in LVM. What are this kind of, what's like, are there additional tools like FileCheck for MLIR in the like most abstract sense that would be really, really beneficial to organize ourselves as a community? For example, like it's Alex graph.
We should fix TableGen.
We should fix TableGen.
No. TableGen is good broken.
Oh, okay, this is the most
because you don't
controversial
overuse.
We had too much agreement on the panel. I had to throw something in, sorry.
yeah.
I thought you were going to suggest we'd replace this course with Git.
No, he was saying that we should replace TableGen with CMake. That's what he said.
I see.
That'd be fantastic. TableGen doesn't have enough strings.
I mean, we can obviously plug IRDL, but then Chris will say that's just a research project that should be deleted. So to make it a little bit more controversial. But I think that's interesting, right?
Yeah, I would try to turn this a bit because I think we seem to all agree that there needs to be some work on like structuring the community. And we might disagree on how specifically it is, and like it's kind of technical. What's interesting to me here is who is going to do that work, who is like willing to do the effort, and who has credibility and maybe authority to do that work. I cannot like just go and pick random person. You were there. You are now in charge of defining what are the different components of
I mean, this is where it's. I think you need to just approach it incrementally and from the top, which is that, the process of sorting a list of things, it's the easiest to take the biggest and, move that. I think that we don't do a service to the community either by assuming that there's like, this has to be completely organized. We are an anarchist collective after all. And the Federalist Anarchist Collective, I guess now. But I think that, if we start minding the house a little bit and boiling out projects, saying this is done, it's 5-year anniversary of MLIR core. Here's what the software tier is. Here's all the stuff. Then that's going to pique people's attention. People, it's a time for self-selection. It's a time for some of this, and we let that organize a little bit. We created this over 5 years. We're not going to like do a sort next month and suddenly be in a good place.
Well, so I agree with you. I mean, nothing can be fixed overnight. That's certainly true. But I think that what the community, and maybe to Alex, your point is, community wants guidance on what success looks like. And
Yeah.
if we can't identify as a team what success looks like, then people continue to pull against. Let me challenge you, Alex. I love you. There actually is a new way to make decisions around here. It's the new governance rule, right? And so one of the things that will happen, I think it was in January-ish, is a new committee is going to be formed to help guide and direct MLIR, right? And so that could help, but it doesn't eliminate the fundamental question of like, how do we actually solve the problem, even if we can make decisions? So one of the things many of us had a conversation on Monday about, which I think would be fantastic. And actually, before I even go there, let me tell you one of the things that bugs me. As a longtime LLVM person that has certainly fond of it and want it to be successful, when MLIR came in, it was a very innovative, new, crazy thing. We were all trying to figure it out. It was in its teenage years. It hadn't grown up yet. And so when it joined, it had a lot of energy and things going on. We wanted to move fast. But LLVM has a number of projects, there are a number of aspects of the way we all function in the LLVM community that forces things to move a little bit slower because we want a higher quality result, and you get a tragedy of the commons when somebody drops something in the tree and now everybody has to maintain it. So one example of this is if you want to add a code generator to LLVM, of course, you can't just say, hey, I invented some new microarchitecture or some new processor. Boom, here's the first third of a target. I'm going to drop it into LLVM. Now everybody gets to maintain it. Now I don't have to merge it anymore. Instead, what we have is we have, a short but a written list of, hey, well, here are the rules to put an experimental target in a tree. And it has to have like some test cases. It doesn't have to be, it doesn't have to be perfect, but there's a criteria. And then here are the rules for it to graduate into a built by default target, right? And it's pretty simple, and lots of people have argued about it. And the consequence of this approach is it means that the things that get into the LLVM tree and therefore have to be maintained by the world, there's like more energy required to reach each of these states, and so it means that the stuff that gets there is more serious. MLIR, in contrast, has allowed lots of stuff to just enter the tree. There's no real oversight. And so coming back to the conversation we had on Monday, something I think would be extremely awesome for both the existing code, but also particularly for new contributors, is if we came up with some kind of schema and said, here's a stable feature, like canonicalize. I think canonicalize, like, fine, maybe it's not done, but it's pretty stable. Like, I think we know what that thing is. Here's an experimental feature. It's still moving, it's still changing in various ways, and it's a different category of expectations where, like, building on this means you may have to do some work, it may be changing, expect debate, whatever, like the expectations are quite different. And here's, I don't know what the label is, a science project. Like,
you want to put it at the top,
no,
right? This is clearly science project that they're
or science project, abandonware, or like, I think we still have the unroll and jam pass.
You just mentioned science project and abandonware in the same sentence.
Well, no, but what I mean by that is I love research, right? So a lot of innovation.
But you guys are useless, so I'm gonna isolate you guys.
No.
Get off the stage.
MLIR came from research, no. But what I mean by that is, like, if we have an unroll and jam pass from 2018, well, that hasn't been maintained, then it being in the tree is actually harmful.
Yep.
And if we think about that, and we just came up with a hierarchy and a set of criteria, then what we could do is we could go around and label things. And what it would do is it would force some questions like, who maintains this code?
Yep.
And if nobody raises their hand, and if it's not fully working and stuff like this, then we could have a separate question of, like, does it belong in a tree? And I think we get to a healthier state for the project, because
and lucky enough, we already have a policy for that, right? For the targets, so we can just repeat the process. Yeah.
And again, this is where MLIR came into the tree, and I think it was good that it was able to move really fast because it was getting figured out and it was innovative, and we didn't know what the outcome and the answers were. But now it's in a different state. Lots of people are coming back to the title. Yes, MLIR is in production. Yes. Lots of people are building on top of it.
Is it ready to be in production, though?
Yes.
Of course it is.
Yeah.
But the problem
by
is
definition, it is in production, therefore it's ready.
But
right?
the problem with the question is it's ill-formed because MLIR is not one thing. And so actually the reality of the world is that parts of MLIR are production, parts are not. And particularly if you're a newcomer coming into the community, you have no idea. And so you pick up something that's attractive and you're like, oh cool, this is gonna solve my problems. And then you're like, oh, MLIR sucks, it doesn't work.
And you get the self-selection where you ask, is this dialect ready? The owner or whoever contributes says, yes, it is. But no, it isn't.
According to their opinion, and there's no criteria.
Yeah, the one guy, exactly. Yeah.
So I mean, what I hear is you're raising like kind of a science quest. I think we like talked about tools for organizing our community. I think we are seriously lacking tools that help us with like this process. And I think the LLVM processes in a way are really sensible to apply to MLIR. But I think there's also really like, in a way, we want to scale these processes. I think we really want tooling. Like I think Alex's MLIR chart is the best example. It's one of the first kind of tools we have to characterize what the community really is. There are many aspects, like the number of commits to like a sub-project, the quality of test coverage, all of these things,
exactly.
which I think all exist kind of individually in our heads.
Help make things quantitative. Right?
But we need tooling to make it quantitative. We need tooling to communicate the knowledge that we have, right? I mean, if I ask you, Chris, which dialect do you think is production ready? You probably know that relatively good for some dialects. No. For others, someone else will know, and others is just...
No, but I mean, if you asked me that, I would have to give you these hearsay answers to your point. Right? It would be like, lots of people use arith, it's a useful thing. Lots of people use linug, it's a useful thing, right? And so, but it's a useful thing doesn't there's no criteria for that. It's just what I hear people use.
Right.
But what I'd also say, just to add color to this, is that how should I say this? Like, MLIR is a top-level directory in LLVM. Like, there can be other top-level directories. We also have incubator projects, like CIRCT. CIRCT's awesome. Like, I love it. And it's done tons of really cool stuff, right? And so there's lots of ways of structuring things other than just throw everything into MLIR. And the flip side of saying MLIR is production is to say, no, not everything under the MLIR tree is production.
Mehdi, you wanted to say something?
Yeah. Just introduce some nuance earlier. Someone, maybe Renato, you were saying like, we look at whether a dialect is production, and the author of the dialect may say yes, some other people may say no. Like, that raises multiple questions to me. First, what does it mean to be production ready is an interesting question in itself.
For that one person, it is in production, but for others, it just doesn't work.
And then being in production is also very contextual. Like, if I take some example, SCF, right? SCF is used by many production tools out there, right? OpenAI Triton, for example, uses SCF, SCF4. It doesn't necessarily tell anything about the SCF dialect as a whole, because SCF dialect is more than SCF4 and SCF-if, which are the main constructs used. There's also a for all and a parallel for with reduction. And even if we look at the parallel for, at some point it got the addition of reduction, which may not be supported in all cases. And so it's very nuanced and subtle when we start talking about those kind of things, and it's difficult to identify what we mean. And even if we take just a single op in a single dialect, it might be, there is the definition. A dialect is first a definition of a semantic that allows you to represent a program, and then there is the incarnation of this op through lowering through specific targets. And the fact that there is an LLVM lowering for that works well on CPU and that is robust for SCF4 doesn't mean much about our GPU implementation or about other contexts.
So that's why you have to escape the is it production question, because it's ill-formed, right? And that's not something that anybody can answer, but you can answer questions like, does it meet its specification, right? Mm-hmm. So let me give you an example of this. I would claim, I believe many people would hopefully agree that arith is a pretty stable and useful thing, right? But on the other hand, to Mehdi, exactly your point, arith is mostly production and stable for scalars and vectors. It also works with tensor, right? And so if there was a discussion about, is this thing stable, what you'd say, well, 2/3 of it is. And then we'd say, are we going to finish the last third, or should that be moved out, right? And I think that is really the question that should be asked. And so if you have this criteria, and to your point, the question isn't, does somebody use it in production, right? Because somebody with an experimental target might say yes, like I use it in production, it's really important to me. That's not the question. The question is, does it have strong maintainers? Does it have tests? Is it satisfying the invariance that the verifier has produced? Yep. Does it meet the semantic requirement? Like, these things are objective, right? And so I think that if you tie it back to...
arith on tensor is a good example, because there's a particular group of people who use arith on tensor, and it's very important for them, but it is not well defined. So for the other people who want to use, either they use in the same way of this group of people, or it doesn't work. So if it's not well defined, then we either make it well defined, or we move it out.
And just from my old school, I care about LLVM more success in the long-term perspective, like I have no stake on like what answer you take, but either make it work or get rid of it. like either way is fine, but doing neither is actually really not fine, right? Because that's actually the problem. That's the state that we're in today, which is still a problem. And so anyways, if we push forward some of the project governance, some of the how we think about things, I think it would force some of these conversations. And then I think that would be very healthy for the project. I think that what that would do is would force us all to have those conversations, have those debates. It would be messy, it would be challenging in some ways, right? But that's how progress is made.
I guess one question, and sort of come back to my previous question, we sort of diverged. I think everybody, or I hope everybody is happy to have the conversation and adopt things, but it's all just work in the end. And how do we make sure all people who contributed don't just say, it's just kind of too much work for me. I'm not going to do it, and nobody else is going to do it. Things just disappear.
Yeah, well, so that comes back to incentives. And so as an open source project, you can't tell people what to do. Like I can't say, like, have one of your students go do this thing that goes and refactors this code. Like that never works. nor can you say, even somebody in good faith, like, you know they want to do that, but it turns out they have a really important P1 project that gets dropped on them, like, and they disappear for a year, right? But from a project perspective, you can say, if you don't do this by this date, we're deleting your code, right? And so if you do that, then what you're doing is you're empowering the stakeholders who care about it to go back and tell their management, I need to allocate time to this thing or else our code's getting deleted. That's bad for us. We need to invest in this. And now there's a really good reason to get the people who care about it to invest time in it. And so if you invert the question from, hey, who wants to make the world be less yucky, to who wants these features to exist, then you get progress. That's how you can actually get people, not because everybody has good intentions. It's not about good intentions. It's about convincing your boss that it's worth you spending time on it, right? And then what you get is, I think you would look at the distribution of the code base and you'd say, some people care a heck of a lot about parts of the code base. And so you get a lot of people willing to step up and say, for a variety of reasons, I'm willing to invest in fixing these issues. Like IREE, I think a lot of people care about that, right? For example. Other people, not to pick on Unroll and Jam, but like, and it's not dialect level, it's much finer grained than that, or maybe parallel 4, or whatever it is. Like if you go and ask these questions and you say, okay, well then let's motivate the stakeholders who care to invest in it. And that's how you get something that's great rather than something that's attractive.
And this works much easier if it's bottom up, right? You have a real problem. I solve this way, you solve the other way, we discuss, and we have this, and then it starts building up. Right? If you try to come top down, like lineage is this, and then you don't even know what this is when you try to lower it to harder, then your discussion is void, right? There's no end to it. So you need to say, okay, I really, for instance, SCF parallel, I want to hoist a configuration file to the thread level, but I don't know if my parallel is one thread per parallel, or if there's more, or if there's more than one parallel per thread, so I can't do the hoisting, right? I have to have something, okay, this parallel is guaranteed to be one per thread, and then I can take semantics. Is this a thing that other people want? I don't know. So we need to talk about the actual implementations. How do we do things? And so just talking about, oh, this dialect uses tensor, therefore no. How does it use tensor, right? Is it just a tensor type, tensor operations, and
well, and this is something that's not obvious, and it's, again, me as an old dog in this world, like, LLVM doesn't have to make everybody happy, right? And so we've gone through this so many times over the decades now, where somebody's like, I'm the Windows maintainer, I'm the only person that cares about this target, but I want to do X and Y and Z and W, and like, maybe they're a jerk about it or whatever, and like, unless you do this, like, whatever, and you're like, well, that's incompatible with our goals. Well, I'm going to leave. It's like, well, leave. And they did, right? And that's very hard. And similarly, when you talk about, another great example of this is there was a hardware company who, very early adopter of LLVM, went and built a really amazing proprietary thing, created a huge number of out-of-tree patches, and did all kinds of cool stuff for their users. Came back 3-4 years later, and they're like, wow, LLVM changed a lot. Now I have to rebase all this stuff. We should have stable APIs. Right? And the answer is like, no, that's not good for the project. And so they're very grumpy and all these things, but it's like, well, the North Star has to be what is good for long-term success and scalability of the project. It's not about somebody grumpy, because people are always grumpy, we're engineers, right? But you have to think about that from a long-term perspective. And this is where I think that, again, LLVM is kind of in the, or MLIR is kind of in a, it's past the adolescent phase. It's now, lots of people want it to be in production. And so I think that the criteria has changed from what it was like when it first entered the monorepo.
I guess one thing I'm wondering is, like, people say, like, we need to define what things are, right? So, we can think about WebAssembly. Like, several people from the LLVM community started to develop or co-develop WebAssembly. And WebAssembly is super strict here, right? There's no WebAssembly feature that doesn't have formal semantics. WebAssembly knows what everything means. It's also a lot slower in kind of getting like more feature, especially formal semantics for like, non-arithmetic starts to become quite complex. So I'm kind of just wanting to throw that in the round. What do we think about this? How formal semantics is one of the most extreme ways to, test and clarify what something means, right? In theory, like Nuno Lopez and John started with like formalizing LLVM Flang ref. Do we need that for MLIR? To which degree do we want it?
I have to answer what MLIR is for that. Like maybe for some parts, but no. If you're just saying what MLIR is now,
Yep.
Subdivide it and say what you.
Yeah, what is
should be
MLIR? Yeah.
I think I'll go even deeper. Is what John was saying is formal semantics is one type of verification of description. You can have multiple types of description and verification. For instance, the example of iteration space in the mapmol versus the floating point precision that you get by reordering things, right? You don't need to care about floating point when you just going back to FP4 or FP2 or whatever. So it's harder to talk about formal semantics in there because there's just too many variations and you can't prove them all. So if you just say, look, I don't want to formally verify it, I just want to make sure that the induction space is the same. And then this is a valid transformation because this is a high level thing. And some people care about the very low level stuff, other people only care about the very high level stuff. But you have to be flexible in there. You can't just say, oh, the lineage has this semantics and I need to prove for every single FP type to every single input type and whatever. It just doesn't, it's not the purpose of lineage to be verifiable, at least in my view, right? It may be the purpose of a RITH or some NVIDIA, Intel, x86 ARM thing, fine. But then they already done this at the, no. But anyway, they should have already done this at the ISA level, for instance. I don't know. So it's, I think there is a place for some verification. I really want to see like verify to be actually useful. But I don't think formal verification throughout the entire space of a floating point or something would achieve that.
Well, I think one of the things you're identifying is that there should be, or it makes sense for there to be different criteria applied to different things.
Yes.
So I think one of the previous amazing talks that was given by some of these folks are like, what are the different dialects? There's border dialects, there's lowering things, there's like these kinds of things. And so if you have a border dialect that's just about ingress from an external community or egress out to another community, we can define that fairly precisely. Like we know the LLVM dialect should implement the same things that LLVM IR does, right? For example, right? And so that would be a place where maybe formal methods could be helpful.
Right.
I would be a little bit concerned about saying like something has to have a formal spec in order to be accepted because then it becomes less inclusive than we probably want. But.
And you can only verify.
When you have a spec.
Sorry, go.
Like all the things that work well seem to be things where there is a spec, and it's kind of a technical solution. Maybe you need to have a spec for what components are, or for what like a spec for people. I mean, going back to what Tobias was saying about structuring the community. Do we need a way to specify who is interested in what and self-describe what you're currently interested in, what is your company willing to invest into, and that kind of stuff?
That becomes like a money fight and.
Well, I mean,
let's be honest, it's part of the job.
One empirical thing that would be cool to do is just like take every file and say, of the last, the data you're producing, Alex, like over the last year, how many commits were changing that thing versus how many commits were just large-scale refactors that touch that thing. Like just look at that distribution percentage. And what that is that's kind of an overly simplified metric that could give you a distribution that says like how much maintenance burden versus how much evolution is happening. Now, some things like canonicalize or I don't know, whatever, are probably done. And so you'd expect that the number of like functional enhancements to it would be low, right? But other things that are less mature, right? You could look at that and say, okay, well, nobody's actually working on this thing.
So we started with a simple question and got to formal verification. So I think the talk is probably done. But we covered canonicalization in the middle, but so we're good.
As we should, yeah.
But everything has been done properly.
Yes.
I do think that if, just to make it super practical, I know everyone has a day job, whatever it is. And I know for my day job, what I care about immensely is that MLIR core itself is an asset I can depend on for the long term, that the software abstractions, the control flow, SCF, LLVM integrations, the GPU dialects, the hardware dialects are well maintained and have good owners. Those are top of my priority list. Right below that is that the classic tensor programming dialects that kind of evolved from XLA TensorFlow into a lot of different shapes and forms. This is part of my day job, and I want to make sure that has that has a center of mass and an owner. And formally verified or not, I'd like those clumps to exist at some point soon and be able to be depended on for the long term and have good maintenance and all that stuff.
Okay, thank you, Stella. I think we are at time, and that's kind of a good conclusion. I would really actually love everybody, both on panel and here, to kind of self-identify what parts of MLIR you care about and ready to commit time and effort to maintain and contribute to. So we have time for a couple of questions from the audience. There are mics in the corridors. No questions. How come?
No, we ended the form of verification. I think people are tired.
Yeah, so sorry about that. I should have moderated that.
Hi. Yeah, awesome discussion, yeah. So I write the MLIR newsletter monthly. I took over from Mehdi, and hopefully you all read it. One problem, thank you. What I find is what Alex showed, right? The number of commits lowering, but also the number of people. So every time I'm trying to write it on a Sunday, okay, I say I'm going to write a newsletter. Okay, what has Matthias done? Okay. So the number of people contributing has reduced a lot. And when these people get moved on to their day job, the improvements to MLIR is going to reduce. And this is, I don't know, industry problem. Everybody working on MLIR has a day job doing something else. So they may not have time to fix the bugs, identify the bugs, etc. I mean, maybe I'm just extrapolating, but you see the problem.
Yeah, I mean, half of the people here are managers of teams.
Yeah.
Are you folks ready to tell somebody your day job is to fix upstream MLIR?
So I answered this in a recent thing of, hey, I've got broad discretion to ask people to do things. I can't flat out tell them to do things. The main thing I can't tell them to do is do something that's going to be painful or ill-defined or, kind of go into a quagmire. And, I think that part of the succession planning for the project and getting it past the first tier of contributors that all have kind of privileged root access to the project, what you're seeing is that those contributors are hitting their hiatus points, and we need to, there's a lot of other engineers who are the day jobs. And, if we organize this a little bit better before the root access people lose attention, I think that we're going to be a lot better at getting, those of us who have a big investment in making this successful, in using all of the enticements at our disposal to ensure succession. But right now it's too disorganized, just too disorganized.
Yeah. Quick answers because we're running out of time.
Yeah. Okay. Well, so the quick answer is everybody. A large majority of the patches that were coming in were coming from Googlers, who then all left, including myself.
Half of the people, more than half of the people here are ex-Googlers.
Yeah, so if you go and run the data and say how many of those patches came from people who were at Google Research, right? That is a change.
Yeah, I wanted to provide a counterpoint because I have a different perspective from what you're saying. I think that we gain in diversity a lot. And so in the early days, the team was very small and very Google focused. And of course, now many of those people spread out to various companies, but even beyond those companies, there are many contributors who have affiliation I don't know. There are many students, many academics who are actually fixing bugs, providing features. And so I see a larger diversity of people contributing these days than there used to be. Another aspect is that you may see less people, but it's also that those people, as MLIR has matured, are busy building project downstream, as we discussed a bit earlier in the time. Right?
Yeah. Okay, thank you.
Thank you, Mehdi, and that kind of answers my question. Sorry, we don't have time for my initial question. Is MLIR dying? No, it's kind of alive and kicking and getting better. It was a provocative question. I had to start a panel to be entertaining. I see there are questions we couldn't answer. We actually have a roundtable in half an hour, and I think 2:45. Instead, big challenges in MLIR. We kind of thought about this problem before, and we see, I think we all collectively see two big issues with MLIR. One is discoverability. How do you know what's there, what it does, how good it is, what it is good for, who do you talk to about it? And another is evaluation. When you come and want to contribute something, what it is a good thing, and what is the overall goal that you can say, is it even worth contributing this thing? Because some of the people wouldn't even come and say, like, maybe it's worthless. And it might end up being super useful for many people. So come to the roundtable as well, and thank you, everyone. Thank you, the panelists.